Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. So in this lecture, I will explain in terms of attribute limit of soil. So hopefully that at the end of this lecture, students should be able to understand the concept of consistency of fine-grained soil. For the introduction, I will explain in terms of attribute limit and why we need to study about attribute limit testing. Means that what is the importance of attribute limit testing. So attribute limit are important because you want to describe the consistency of fine-grained soil. You need to remember that consistency of soil actually only occur on fine-grained soil, especially in clay soil. Okay, so the knowledge of soil consistency is important because we want to define, we want to classify, or we want to predict our soil performance when used in construction material. So, what is soil consistency actually? The first thing is, consistency is a term which is used to describe the degree of firmness of cohesive soil by using descriptions such as a soft, medium, stiff, or hard. So the amount of water in the soil determines its state or consistency. Means that different amount of water will give different consistency of soil. So each state, consistency and behavior of the soil is different as well as their engineering properties. So the water content at which consistency changes from one state to the other state we call as consistency limit, or also we can also use the term attribute limit. Attribute limit or consistency limit is actually the same thing that we want to describe in terms of consistency of soil that changes depends on water content. So four states are used to describe the soil consistency, which consist of solid, semi-solid, plastic, and the last one is liquid. Okay, now in this slide, I want to explain in terms of this diagram. So this diagram we call as a consistency soil diagram. So in y-axis we have a volume of soil, and then in x-axis we have water content. So attribute limit are the limit of water content we use to define the soil behavior. Okay. When water is added to the soil, it will change soil consistency and also texture of soil. So what is soil consistency? If you look at here is water content. So when we add water into the soil, from solid, the soil can change into semi-solid. It also can change plastic. And the last one, it will become liquid based on its water content. Okay, so means that we can conclude as depending on water content, soil may be appear as solid, as semi-solid, as plastic, and liquid. To simplify, here is a definition for each state: liquid limit, plastic limit, and shrinkage limit. So what is liquid limit? Is defined as the moisture content at which the soil ceases to be liquid and become plastic. And for plastic limit, as a PL is defined as the moisture content at which the soil ceases to be plastic and become a semi-plastic solid. And the last one is a shrinkage limit, or we noted as a SL, is defined as the moisture content at which no further volume change occur with further reductions in moisture content. In lab, we have two different types of testing to determine our liquid limit. So either you are using CPT, cone penetration test, or the second one is using Casagrande test. So here is the picture to represent both testing. For the full procedure is already mentioned in video. So in my slide, I just explain a simple procedure how to conduct both testing. For CPT, first of all, for both soil, first of all, we need to make sure that we use a fine soil, that the soil must be passing 0.425 micron size. Okay, then the fine soil must be added with distilled water. We put distilled water and we mix together the soil until the soil become homogeneous paste. After that, we put our soil in this cup. And then we place the soil on the base. What happens is this is cone, so the cone is lowered so that it just touch our soil. Make sure that the needle must be at 0 value, and then the cone is released to penetrate the soil paste for exactly 5 seconds, and you can record the data. You can record the data of penetration value and take an amount of soil for the moisture content determination. Okay, you need to remember that actually for CPT, liquid limit occur at 20 mm penetration, but since it's difficult to nail the exact water content required to penetrate at 20 mm for the first trial, so several attempts have been made. So at least in lab we conduct at least 4 to 5 testing. Okay, we move to the Casagrande testing. So how we want to perform this lab is actually same like CPT. The soil must be passing 0.425, and then we add with distilled water, we mix together until the soil become paste, and then put into this cup. Okay, after that we use these grooving tools. We will groove at the center so that the soil will split into 2 parts. Then you adjust the height, and then using this crank handle, you rotate at a 2 rotational per second until the soil become into contact at the bottom part. With a distance, you can measure the soil that become contact is around 13 mm value, 20 mm value. And then take an amount of soil for the moisture content determination. Okay, for the plastic limit, actually for plastic limit, there is no apparatus needed. So just make a ball shape of your soil, and then divide into 4 portions, and then you roll your soil on the glass plate until your soil start to crumble. So means that to obtain the plastic limit roll, we call as worm of soil until they just start to crumble. Then you put into the moisture cup for the water content determination. But you need to be aware that keep the soil you are not rolling under a moist paper towel to avoid from drying out. The second thing is also try to avoid rolling on your finger. You cannot roll on your finger. What you should do is actually you roll your soil on the glass plate. Okay. So here is the data analysis for cone penetration testing. Actually, in this slide, I want to explain how to determine the moisture content. But first of all, like I mentioned before, what you need to do is actually after each testing, you need to take an amount of soil for the moisture content determination. And first and foremost, what you should do is actually you need to weight your container. Make sure that you weight your empty container, and also when you take an amount of soil, then again you need to record your mass of container plus wet soil, and then you put into the oven. After take out from the oven, make sure to measure the mass of container plus dry soil. And then you can measure your dry soil, which is this value, divide by container. And then you can also measure the moisture loss, which is wet soil minus with dry soil. Okay, to get the value of moisture content, you can using the formula that you studied from ECG 243, which is mass of water divided by mass of solid. After you complete your calculation, so what is the next step is actually we want to plot into the graph. Okay, now so we will proceed with plotting a graph. So in your y-axis is a penetration value, in your x-axis is your value for moisture content. Then after you plot your graph, have a best fit line. Okay, like I mentioned in a previous slide, your liquid limit for CPT is actually occur at 20 mm penetration. So on the graph at 20 mm penetration, drag off your value until it intersect your best fit line. Then you read off the moisture content value. So in this example, your moisture content occur at 68%. So means that here is the value for liquid limit for CPT testing. Okay, next we move to the Casagrande testing. For Casagrande testing, we will using a log graph to plot your graph later on. But for the data analysis, same like CPT, you also need to measure the mass of container plus wet soil that you take from your cup, an amount of soil, and then you put into the oven After 24 hours, you take out, then make sure to weight again your container plus dry soil, and then measure dry soil and also moisture loss. To determine your moisture content here, using a formula which is mass of water divided by mass of solid times by 100. Don't forget to times by 100. After you get all the moisture content value, then using our log graph, we need to plot your value of moisture content versus with number of tap. Okay, for a liquid limit at Casagrande testing, liquid limit occur actually at 25 number of blows or 25 numbers of tap. So here at 25, drag off the value and until it touch your best fit line graph, and then read off the moisture content value to the nearest whole number. So here is your liquid limit for Casagrande testing. Okay, next. Okay, in this slide is actually the result for plastic limit. I just want to inform that for plastic limit, there is no graph plotted. So you need to calculate your moisture content. Your moisture content is actually your plastic limit value. Okay, so how to calculate is same as your previous one. So now we move to the plasticity index. So what is plasticity index? So the difference between liquid limit and plastic limit is actually your plasticity index, or we note it as a IP. Okay, so after you find your LL and also your PI, what should we do is actually we want to classify our soil. You need to remember that our main purpose of this testing is actually we want to classify our soil. Either our soil is clay or silt. Okay, so using this chart, this is we call as a plasticity chart. Okay, this align to split or to divide clay and silt. Okay, on the upper part is clay, so we have Cl, Ci, Ch, Cb and Ce. So C represent clay, for M represent silt. So L is low plasticity clay, I is intermediate plasticity clay, H is high, V is very high, and the last one E is extremely high plasticity. So for same goes to silt. Okay, L, I, H, V, E is the definition of each names. Okay, so how to read the value of plasticity chart? How to classify our soil? Okay, I give an example. If let's say your value for PI is around 40%, okay, 40%, and your value of liquid limit is 60. Okay, then you drag your value of 60 and also 40, where it cross each other, it cross here. So means that your soil is CH. So what is CH? CH means that your clay in high plasticity. So here, this is how you name your soil type, how you classify your soil types. Hopefully that you understand how to classify your soil types. So in this slide, I would like to explain in terms of liquidity index. What is liquidity index? Is actually a measure of soil strength using attribute limit and the relationship of the soil natural water content. So IL come from this formula, W minus with WP divided by IP. So W is actually natural water content, WP is your plastic limit value, and you divide with your IP. So this is very important because we want to study about strength of soil based on attribute limit. So in this slide is a description of strength for fine grained soil based on liquidity index value. Okay, if let's say your Li is less than 0, means that your soil in a semi-solid state. So it have a high strength, brittle and sudden fracture is expected. If let's say your soil is within 0 and 1, your soil is exhibit plastic state and its strength is intermediate strength. And if your Li is greater than 1, means that your soil in a liquid state. And the strength is low in terms of strength and soil deformed like a viscose fluid. So why we need to study in terms of liquidity index? Because since we are engineer, we are very interested in the strength and deformation of material. So we can associate specific strength characteristic with each of this soil state. So at one extreme, at this liquid state, soil has the lowest strength and the largest deformation. But in the other extreme state, which is in solid state, the soil has the largest strength and the lowest deformation. So we know that when we get the value of Li, we can determine our strength based on Li value.